So we were discussing order of reaction, and I also mentioned about molecularity of a reaction. Order of reaction was x plus y, and molecularity was simply given by a plus b, or whatever the addition of the stoichiometric coefficient. Most of you have a doubt between the relation between order and molecularity. Let us, for example, take the same reaction. A plus bb gives you cc plus dd. What is rate law for this reaction? R is equal to k, a raised to x and b raised to y, right? And what is molecularity here? Molecularity will be a plus b, and what will be the order? Order will be x plus y. We have to understand that x plus y may or may not be equal to a plus b. Now, when will be it equal and when it won't be equal? Okay, so as we discussed last time, order will be equal to molecularity if and only if the reaction is single step. For a single step reaction, it can be also called a simple reaction, or it can be also called as elementary reaction. Okay, so this is it. If they mention that the reaction is single step, if they mention the reaction is simple step, if they mention that the reaction is elementary, then you have to take this condition, that is x plus y is equal to a plus b. If it mentions, okay, like for example, if I say this example, H2 plus O2 gives me H2O, and to balance we write 2 here and 2 here, right? So R will be equal to K, H2 raised to something x and O2 raised to something y. This x, if I say if this is a single step reaction, so x will be 2 here and y will be 1 here, if it is mentioned. Otherwise this is not possible, this is not there, x won't be equal to 2. So next question, if x is not equal to 2 here, or for any other reaction apart from single step or simple reaction, how would we decide order if conditions are not mentioned? Okay, so the reaction which does not occur in single step, we call it multiple step reaction, or mostly complex reaction. So it is known as complex reaction or multiple step reaction, right? Simple example that day we gave for the formation of sodium chloride, Na plus, let's take half Cl gives me half Cl2 gives me NaCl, right? Now this reaction takes place in number of steps. So the very first step is sodium solid gets converted into sodium gas. Next step will be chlorine, Cl2 of Cl2 molecule will get converted into chlorine atom. Now next step, Na plus, so Na, that is the gaseous sodium atom, gives 1 electron, so that becomes Na plus. After Cl generated, takes 1 electron to give you Cl minus, and then Na plus plus Cl minus attract each other to give you NaCl. Now if you see this reaction, along with this step there were 2 more steps, that is Na solid gets converted to Na gas and Cl2 gets converted into Cl. Now if you see, the reaction is happening in this number of steps. Okay, so what is the rate law for this reaction? R is equal to K, and what is the order? Okay, order will be decided by writing rate law. This equation R is equal to K, A raised to N, is something known as rate law. So we have to decide the rate law. Okay, in such step reaction, in such multiple step reaction, the slowest step, you have to understand, slowest step is RDS. What is RDS? Rate determining step, means the rate will be decided by the slowest step. Like for example, if I say this is the slowest step, the first step is the slowest step, if I say this, okay, so that means the slowest step is the rate determining step. तो इसका जो भी reactant है, whatever is the reactant of the slowest step comes here. R is equal to K Na raised to कितना है, how many reactant, 1, then 1, the slowest step. Now to understand more clear, okay, we take an example. The best thing is Maggie. Okay, we know that Maggie, in the ad it says that Maggie is made in 2 minutes, but हमको मालूम है Maggie 2 minutes में नहीं बनता. So why is it known as 2 minutes Maggie? Okay, so let us see preparation of Maggie. Preparation of Maggie takes place in 2 steps. 2 steps में होता है. The first step is you boil. I'm talking about simple Maggie, like boiling of water and then we put the Maggie. That is how Maggie is supposed to be made. We Indian make it in different forms. That's a different thing. Okay, so the first thing is boiling of water. Okay, and the second step is you put the Maggie in boiling water. Now if you see why it is known as 2 minutes Maggie, so it is known as 2 minutes Maggie because boiling of water takes place at a slower step, slowest rate I can say. So this is slow step and this is fast step. Okay, so that means when you're boiling water, when you're preparing Maggie, maximum time is consumed in boiling water, not in putting that Maggie. Okay, once the water boils, it hardly takes 2 minutes for the water to boil, and once the water boils, you put the Maggie and Maggie is prepared, and that is why it is known as 2 minute preparation. Okay, so that means boiling of water is the first step, which is the slowest step, and hence the rate means the ad says it's 2 minutes Maggie, so the rate is determined by the first step, that is the slowest step. Okay, even though the reaction involves 2 steps, but since this step takes place slowly, the rate is decided by the slowest step. Okay, like for example, if we are again another example is like if we are going on a picnic, okay, and we start the journey by 7 a.m. but one of the student, like everybody reached there by 6:30. You are advised to reach by 6:30 and everybody reaches on time. Okay, and the bus is supposed to start at 7, but one of the person comes at 7:15. Okay, so we cannot start the journey until each and every person comes. So when are we going to start the journey? According to the fastest person or according to the slowest person? We'll start the journey according to the slowest person. Okay, that means he is the determining factor. Okay, so similarly the slowest step will be the rate determining step. Okay, and from this we conclude that this is the first order reaction since you have 1 year, right? So that is order and molecularity. The difference between order and molecularity should be clear here. And for multiple step reaction you have to decide how are you going to find the slowest step and how are you going to find the rate law or the order of the reaction. For a multiple step, there are 2 more points to be noted. That you see that like in the first step you see sodium is formed and Na plus is formed here. Okay, and you see in one step Na plus gets consumed. Such thing which is formed in one step and consumed in another step is known as reaction intermediate. You have to note it, you have to write it down in your notebook. What is reaction intermediate? It is formed in one step and consumed in another step. That means in the overall reaction you won't find, okay, it is formed during the reaction and consumed during the reaction. At the end you won't find reaction intermediate, and most of the time there's something which we take initially and we get the finally also, that is known as catalyst. We all know what is a catalyst, right? Catalyst is something which will increase the rate of the reaction. Okay, so for catalyst we need, how would we identify? Okay, definition मालूम है but identify कैसे करेंगे? Okay, so we have to understand that catalyst is used, usually it is used in the reaction, used in the first step I can say, okay, to initiate the reaction and obtained in the last step. मतलब फर्स्ट स्टेप में यूज होगा, लास्ट स्टेप में वापस मिल जाएगा as it is. Okay, so if there is species which you see, which is used in the first step, and then you're getting back in the last step, it is known as catalyst. So you have to identify this also: reaction, intermediate, and catalyst for a complex reaction. Okay, so most of us have that doubt, what is the difference between order and molecularity. So this is, if I'm still not clear, let me know. Okay, we proceed with order. Okay, so that day we discussed that order can be zero, order can be fraction, order can be integers, but it cannot be what? It cannot be zero. It cannot be negative. So that is order. Okay, now on the basis of order, I can classify reaction. We can classify reaction as many types, like for example, first order, second order, zero order. Okay, this classification is needed for further study. What is the first order reaction? Where x plus y, or maybe only x, is equal to 1. That is, the total order of the reaction with respect to all the reactant will be 1. That is known as first order reaction. Okay, now the question arises, what is zero order reaction? Why it is? So zero order reaction is a reaction in which the rate of the reaction does not depend upon amount of the reactant. Like for example, if we have been in the lecture, in my lecture, we know that I usually take sodium. Okay, हमने sodium किसी के टकले पे रखा था, we know that उसका टकला जल जाएगा. Now it doesn't matter how much sodium you take. Okay, you just keep it in somebody's head and it will, you know, वो तुरंत जल जाएगा. वो मैटर नहीं करता कि आपने सोडियम कितना लिया है. सो यहाँ पे द रेट ऑफ द रिएक्शन, मतलब रिएक्शन कितने फास्ट होगा, वो इस पे नहीं डिपेंड कर रहा है कि आपने सोडियम कितना लिया है. सो द रेट ऑफ द रिएक्शन डज नॉट डिपेंड अपॉन द कॉन्सेंट्रेशन ऑफ द रिएक्टेंट. ऐसे रिएक्शन को हम लोग बोलते हैं जीरो ऑर्डर रिएक्शन. इज दैट क्लियर? ओके, सो फॉर मूविंग फर्दर, दिस इज स्पेशल टाइप ऑफ रिएक्शन विच इज नोन एज सूडो फर्स्ट ऑर्डर रिएक्शन. सूडो मतलब सुना रहेगा कभी. सूडो मतलब फॉल्स first order reaction. False means it is a reaction. How we define pseudo first order reaction? So definition, again we have to look from the textbook, but I'll define it. The reaction which appears to have higher order kinematics but behaves as first order reaction. Kinematics मतलब the study of rate is known as kinematics. Okay, तो देखने से आपको ऐसा लगेगा अरे ये फर्स्ट ऑर्डर, ये हायर ऑर्डर है, बट एक्चुअली वो फर्स्ट ऑर्डर बिलीव करता है. लाइक फॉर एग्जांपल, टेक द सिंपलेस्ट एग्जांपल, हाइड्रोजन प्लस ऑक्सीजन गिव्स यू H2O. ओके, हाफ ऑक्सीजन है टेक. नाउ अगर आप इसमें देखोगे, इफ यू राइट रेट लॉ, R इज इक्वल टू K, H2 rates to, let's say it's a simple step reaction, single step reaction, or let us just consider hydrogen raised to 1 and oxygen raised to half. So if you count, if you add 1 plus half will be 1.5. तो आप बोलोगे the rate of the order of the reaction is 1.5 year. Okay, मतलब that should be the minimum, I guess. मतलब, और अगर आपने एक ऑक्सीजन का भी लिया तो वो 2 हो जाएगा. So if we see, we find it like यार ये फर्स्ट ऑर्डर से ज़्यादा ही होगा, but it may be a first order also. Now the question is how. Okay, so अभी hydrogen and oxygen, we know that air contains lots of oxygen. Okay, like for example if we burn something, okay, like हम लोग ने बचपन से एक एक्सपेरिमेंट करते आते हैं बर्निंग का, कंबशन का. मैग्नीशियम बिन बर्न इन एयर गिव्स यू मैग्नीशियम ऑक्साइड. ओके, तो आपको कितना मैग्नीशियम ऑक्साइड मिलेगा, दैट डिपेंड्स ऑन व्हाट, आपने कितना मैग्नीशियम लिया और कितना ऑक्सीजन है. ओके, बट एयर में एक्चुअली ऑक्सीजन इज़ इन एक्सेस क्वांटिटी. एक्सेस क्वांटिटी मतलब ऑक्सीजन नॉर्मली बहुत ज़्यादा क्वांटिटी में होता है एयर में. ओके, तो आपको एंड में मैग्नीशियम ऑक्साइड कितना मिलेगा, दैट डिपेंड्स आपने इनिशियली मैग्नीशियम कितना लिया था, बिकॉज ऑक्सीजन भर के हैं, राइट. सो दैट मीन्स योर ऑक्सीजन इज़ इन एक्सेस, मतलब ऑक्सीजन बहुत ज़्यादा है. तो ऑक्सीजन की क्वांटिटी से फ़र्क नहीं पड़ेगा कि आपको वाटर कितना मिलेगा. ये आपने बायो में भी किया है, फोटोसिंथेसिस में. ओके, वी हैव डन दिस इन लाइक आई गेस मैम ने आपको बताया रहेगा. तो लिमिटिंग फैक्टर, एंड इवन इन केमिस्ट्री वी हैव डन इन द वेरी फर्स्ट चैप्टर लिमिटिंग इन एक्सेस रिएक्टेंट. ओके, लाइक फॉर एग्जांपल फोटोसिंथेसिस की बात करेगा तो इट डिपेंड्स अपॉन अमाउंट ऑफ I can say carbon dioxide, water and light present. Okay, but during the day time अगर light बहुत ज़्यादा है, that is sunlight बहुत ज़्यादा है, तो वहाँ पे दो फैक्टर पे डिपेंड करता है, कार्बन डाइऑक्साइड एंड लाइट. अगर कार्बन डाइऑक्साइड, एक प्लांट ऐसे एरिया में लोकेटेड जहाँ पे कार्बन डाइऑक्साइड कम है, तो वहाँ पे रेट ऑफ द रिएक्शन मतलब फोटोसिंथेसिस कितना होगा वो किस पे डिपेंड करेगा, कार्बन डाइऑक्साइड पे. वो वाटर पे डिपेंड नहीं करेगा और ना ही वो सनलाइट पे डिपेंड करेगा. सो योर इट डिपेंड्स ओनली वन फैक्टर, राइट. तो अब हमको लगा वो बहुत ज़्यादा फैक्टर्स पे डिपेंड कर रहा था, बट वो एक ही फैक्टर पे डिपेंड किया. ओके, तो सिमिलरली ऐसा रिएक्शन जो आपको लगे वो हायर ऑर्डर है, बट काइनेटिक्स जब आप उसको देखिए, जब आप उसका मैकेनिज्म देखोगे, तो अगर आपको वो फर्स्ट ऑर्डर लगा, वैसे रिएक्शन को हम लोग बोलते हैं सूडो फर्स्ट ऑर्डर रिएक्शन. ये बोर्ड पॉइंट ऑफ व्यू एक क्वेश्चन है, व्हाट इज सूडो फर्स्ट ऑर्डर रिएक्शन, एक्सप्लेन विद एग्जांपल. तो यू हैव टू एक्सप्लेन. If it's still not clear, I have a better example. Like for example, let's say our friend Sumit is getting engaged, and he gave the arrangement order to one of his another friend. Okay, like लोगों को चाय पानी वगैरह का. So his friends decides that I'll save some money of Sumit and I'll serve people rasna instead of coke and all. Okay, so when you are talking about engagement, you are not making rasna as 1 glass or 2 glass, so you take the rasna in excess quantity. तो उसने क्या किया, उसने बहुत ज़्यादा पानी ले लिया, लाइक ड्रम भर के पानी ले लिया. ओके, नाउ द टेस्ट ऑफ rasna will depends on two factor, the amount of water taken, पानी आपने कितना लिया, एंड आपने rasna कितना लिया है. बट क्योंकि इसने पानी बहुत ज़्यादा ले लिया है, राइट, पानी पहले से ड्रम में भर के रख दिया, ही इज़ नॉट गोइंग टू चेंज द अमाउंट ऑफ वाटर. ओके, पानी और चेंज करने वाला नहीं है, एंड ही इज एक्टिंग पैकेट्स ऑफ रसना एंड टेस्ट कर रहा है. अच्छा, अभी बना क्या. ओके, सो अब जो टेस्ट ऑफ रसना होगा, दैट विल डिपेंड अपॉन व्हाट, वाटर और ओनली ऑन द पैकेट ऑफ रसना, ओनली ऑन द पैकेट ऑफ रसना, बिकॉज वाटर ऑलरेडी बहुत ज़्यादा एक्सेस क्वान्टिटी में है. इज दिस क्लियर? सो सूडो फर्स्ट ऑर्डर रिएक्शन भी क्लियर. ऑर्डर का मतलब आई गेस अभी क्लियर हुआ है आपको, व्हाट इज ऑर्डर, व्हाई डज इट डिपेंड अपॉन दिस थिंग, राइट. So that is order, pseudo first order reaction, and then we discuss what are the different types of reaction on the basis of order. So we have first order, second order, zero order. You can have n number of order, but for us we have derivation for zero order and first order reaction. Okay, in the last lecture we also discussed about how to find the order of the reaction using conditions, and I gave you two methods. Okay, one was the HSE method. Okay, that is like what are you going to use for the HSE, how we are going to solve systematically, since this is 3 marks or 4 marks, so we need to solve calculation. But in CET or your JEE or NEET, I give you a simple shortcut, right? So what I want is, I want you to revise that once again. You have to learn that how to use that shortcut. Okay, because this is easy, this has to be applied for J. Okay, we need a little bit of application of brain. So today's lecture I'll conclude here. With this we will end order and molecularity. So for the next lecture, when I'm making for the next lecture, I want the order and molecularity rate to be at rate law to be at the back of, मतलब वो अच्छे से लर्न होना चाहिए, नहीं तो आगे का जो पार्ट है that becomes difficult. Okay, I'll not go back and explain again. Okay, thank you.